Tonight, we are going to talk about a prison, not one made of steel bars or concrete walls, but one built out of the single fastest thing that exists in the entire universe. A prison so well disguised that most people go their whole lives without ever noticing they're standing inside it because the bars aren't visible and the walls don't look like walls. They look like light. They look like the ordinary, everyday experience of seeing, of knowing, of simply glancing up and taking in the world around you. And yet, once you understand what the speed of light actually costs you, you start to realize that now is not a word you're ever allowed to use honestly about anything beyond your own immediate skin. Because here is the thing almost nobody sits with long enough to feel its full weight. Light is fast, unimaginably fast. Nothing in this universe moves faster. And yet, even at that staggering speed, light still takes time to travel. And that time, no matter how small it seems at human scale, quietly erases the very idea of a shared present moment between you and almost everything else that exists. You are not living in the same now as the sun. You're not living in the same now as the edge of your own galaxy. You are not even, in the strictest sense, living in the same now as the person sitting across the room from you, though the gap there is so small it might as well not exist. But stretch the distance out, star by star, galaxy by galaxy, and the gap stops being trivial. It becomes a wall, a permanent, physical, mathematically unbreakable wall between you and the present tense of the rest of the universe. By the end of tonight, you're going to understand exactly why this is true and just how deep the consequences actually run. You'll understand why a message sent to Mars cannot ever have a real conversation, why the sun you see every single day already stopped existing 8 minutes ago as far as your senses are concerned, and it just hasn't caught up to you yet, why entire civilizations, if they exist at all, could be broadcasting to us right now, and we would have no way of knowing for centuries. You'll understand why the light speed limit isn't simply a speed limit for travel. It's a speed limit for reality itself, for knowledge, for connection, for the very concept of simultaneity. It is a prison with walls made of time, and every single one of us is serving out a sentence inside it, whether we've ever noticed the bars or not. Before we get into it, if slow, careful explorations of the actual physics behind our place in the universe are something you enjoy, take a moment to like this video or subscribe. It costs nothing, and it helps this kind of long, patient exploration find its way to more curious minds. Now, let's step inside the cell and start to understand exactly what it's made of. Let's start with the number itself, because most people know the phrase speed of light, without ever actually holding the number in their hands. Light travels at approximately 186,000 miles per second, not per hour, per second. In the time it takes you to blink, light could have already circled the entire Earth more than 7 times over. It is, by an enormous margin, the fastest thing in the observable universe. And as far as we know, based on more than a century of rigorous experimental testing, absolutely nothing with mass can ever reach it, let alone exceed it. This isn't a limitation of our engineering. It isn't something a smarter species or a more advanced civilization could simply build their way around. It is baked directly into the geometry of space-time itself, described with extraordinary precision by Einstein's theory of special relativity, published in 1905. As an object with mass accelerates closer and closer to the speed of light, the energy required to continue accelerating grows without limit, approaching infinity as your speed approaches light speed itself. To actually reach the speed of light, an object with any mass at all would require an infinite amount of energy, which is another way of saying it is not merely difficult. It is, under the physics as we currently understand it, impossible. But here's the detail that most casual explanations skip entirely. The detail that turns this from an abstract cosmic speed limit into something that reaches directly into your living room tonight. The speed of light isn't just a ceiling on how fast things can move. It's also the speed at which information itself travels. And information includes something you might not have thought to include: your own perception of reality. Every single thing you see right now, in this exact moment, is not actually happening right now. It is light that left its source some amount of time ago, however small, and has only just now arrived at your eyes. You are not seeing the present. You are seeing a very slightly, or in some cases, an enormously delayed recording of the past, and your brain, without your permission, stitches all of these delayed recordings together into something that feels like a single, unified, simultaneous now. This is the beginning of the prison, not some distant abstract concept relevant only to astronauts and astrophysicists, but something operating on you, constantly at every scale, from the person standing 3 feet away from you to the most distant galaxy any telescope has ever captured. The wall is invisible because it moves at the speed of light itself, faster than anything you could ever notice directly, but it is there, and once you start looking for it, you'll find it everywhere, hiding in plain sight inside the most ordinary experiences of your entire life. Let's make this personal before we make it cosmic, because the prison doesn't begin somewhere out in deep space. It begins right here, in the room you're sitting in. When you look at a friend sitting across a table from you, perhaps 6 feet away, the light bouncing off their face and traveling to your eyes takes about 6 nanoseconds to make that trip. 6 billionths of a second. That delay is so small that no human nervous system could ever consciously register it. So for all practical, everyday purposes, you really are seeing your friend in the present moment. The prison walls at this distance are close enough to be functionally invisible. Now expand the distance. If you're watching a football game live from the upper deck of a large stadium, several hundred feet away from the field, the light delay is still only a fraction of a millionth of a second, still completely undetectable by any human sense. If you're on a video call with someone on the other side of the planet, the delay grows into something you can actually notice, a few tenths of a second, caused partly by the finite speed of light traveling through fiber optic cables and partly by the processing time of the equipment involved. But even that delay, small as it feels, is a direct physical consequence of the exact same limit that governs everything else we're going to discuss tonight. There is no version of instantaneous communication across any distance. Not now, not ever, not with any technology we can currently imagine building. The wall is always there. It only becomes obvious once the distance grows large enough. And distance, in this conversation, grows very large very quickly. Consider the moon, the closest large object beyond Earth itself, sitting about 239,000 miles away on average. Light takes about 1.25 seconds to cross that distance. During the Apollo missions, that delay was a constant, tangible presence in every single exchange between the astronauts and mission control back on Earth. A 2.5-second round-trip lag baked into every question and every answer. Imagine trying to have an ordinary conversation with someone where every single sentence you say takes over a second to reach them, and every response takes over a second to come back. And you start to understand how quickly even a very small distance begins to interfere with the simple human experience of talking to another person in real time. And the moon, in the grand scheme of everything we're about to cover tonight, is essentially standing right next to us. Move outward to Mars, and the prison walls start to close in with real consequence. Mars orbits the Sun at an average distance of about 142 million miles, compared to Earth's 93 million. And because both planets travel along their own separate orbits at different speeds, the actual gap between us varies enormously depending on where each planet happens to be at any given time. At closest approach, Mars comes to within about 34 million miles of Earth. At its farthest, when the two planets sit on opposite sides of the Sun, the gap stretches to roughly 250 million miles. At closest approach, a radio signal takes about 3 minutes to make the one-way trip. At farthest, over 20 minutes. 3 minutes sounds almost reasonable until you actually try to build a conversation around it. Every basic exchange between Earth and Mars carries a minimum 6-minute round-trip delay, and that's on the best possible day, when the planets happen to be favorably aligned. If something unexpected happens on the Martian surface, if a rover hits a hazard or a piece of equipment fails, mission control on Earth won't know about it for at least 3 minutes after it occurs. And any corrective instruction sent in response won't arrive for 3 minutes after that. This is exactly why Mars rover operations have never worked like remote-controlled cars. They work more like sending letters across an ocean. Engineers plan entire sequences of actions in advance, transmit the whole batch at once, and then simply wait, sometimes for hours, to find out what actually happened on the other end. Now think about what this actually means for the dream of a real-time human presence on Mars. Even in the most optimistic future imaginable, one where humans are permanently living and working on the Martian surface, mission control back on Earth will never be able to have a live, real-time conversation with them. There will always be, at absolute minimum, a 3-minute delay in each direction, stretching to over 20 minutes during unfavorable alignments, an entire month-long stretch known as solar conjunction. When Mars passes almost directly behind the Sun from Earth's perspective, during which communication becomes so degraded by solar interference that mission controllers essentially go silent for weeks at a time, unable to reliably talk to their own colleagues on another world at all. This is our nearest serious planetary neighbor, the destination we are actively planning crewed missions toward, and the speed of light already guarantees that no human being standing on its surface will ever be able to have an ordinary real-time conversation with anyone back home. The prison doesn't wait for you to leave the solar system. It starts enforcing its walls the moment you leave your own planet. Push outward past Mars, past the asteroid belt, and the delays start to stretch into something that stops feeling like an inconvenience and starts feeling like genuine isolation. Jupiter, the largest planet in our solar system, so massive that more than 1,300 Earths could fit inside its volume, sits at an average distance of about 483 million miles from the Sun, and a radio signal traveling from Earth takes between 33 and 52 minutes to arrive there, depending on where both planets happen to be in their orbits. Saturn, with its extraordinary rings spanning roughly 170,000 miles in diameter, sits at about 886 million miles, with signal delays stretching to 70 or 87 minutes. Uranus pushes that delay past 2.5 hours. Neptune, the outermost major planet in our solar system, sits about 2.8 billion miles from the Sun, with a one-way signal delay of roughly 4 hours. We have actually sent a spacecraft to Neptune. Voyager 2 launched in August of 1977 and arrived in August of 1989, a full 12 years later, for a single, irreversible flyby. No orbit insertion, no landing, just one close pass to gather as much data and as many photographs as possible before continuing onward into the darkness beyond. Every single image Voyager 2 captured of that brilliant blue world and its frozen, geyser-scarred moon Triton arrived back on Earth, carrying a 4-hour delay, meaning the engineers and scientists monitoring the mission were, in a very real sense, watching events that had already finished happening a full 4 hours earlier. By the time confirmation arrived that a critical maneuver had succeeded, 4 hours had already passed since it either worked or catastrophically failed. 4 hours during which the outcome was already fixed and unchangeable, and the people back on Earth simply didn't know it yet. This is the essential unsettling nature of the prison we're describing tonight. It isn't that distant events are unknowable. Eventually, the light carrying the information does arrive, and we do find out what happened. It's that there is no way to know anything as it happens. Everything beyond your immediate vicinity exists for you only in the past tense, delivered on a delay that grows in direct proportion to distance, with absolutely no way to shorten that delay, ever. No matter how clever the technology involved, you are not simply far away from Neptune. You are, in the most literal sense that physics allows, permanently 4 hours behind it, and that gap will never close, not with better engineering, not with faster processors, not with any advance in communication technology we could ever hope to build. The delay is not a limitation of our equipment. It is a limitation of the universe itself. Now, consider Voyager 1, the most distant human-made object in existence, still traveling outward, still transmitting a faint signal back toward Earth after nearly 50 years of continuous flight. Today, Voyager 1 sits more than 15 billion miles from the Sun, and a radio signal from it takes over 22 hours to reach us. 22 hours, one way. If an engineer at NASA's Jet Propulsion Laboratory sends a command to the spacecraft today, the confirmation that it even arrived won't come back for nearly 2 full days. A single question and its answer, the most basic unit of conversation there is, now takes the better part of 2 days to complete. Think about what that actually does to the experience of operating that spacecraft. There is no troubleshooting in any conventional sense. If something goes wrong, the engineers on the ground are working with information that is already nearly a full day old by the time they see it, and any fix they send won't take effect for almost another full day after that. They are not managing a spacecraft in real time. They are managing a spacecraft in something closer to a very slow, very patient correspondence with a colleague who only writes back once every 2 days, except the colleague is a machine hurtling through interstellar space, and every single exchange might be the last one because the plutonium powering its systems is slowly, irreversibly running out. And here is the detail that should genuinely unsettle you, if you sit with it long enough. Voyager 1, at 15 billion miles and a 22-hour signal delay, is still, by the standards of the rest of this program, essentially in our own backyard. It has not even reached the inner edge of the Oort cloud, the vast, distant shell of icy debris that marks the true outer boundary of our own solar system's gravitational influence. A boundary Voyager 1 won't reach for approximately another 300 years, and won't fully cross for another 30,000 years after that. The prison we're describing tonight doesn't require you to leave the solar system to start closing in around you. It's already closing in around a spacecraft that hasn't even left our own cosmic backyard, and the delay it's already experiencing, nearly a full day for a single question and answer, is going to look almost laughably small compared to what comes next. Cross the true boundary of our solar system, out past the Oort cloud, into the open gulf of interstellar space, and the delays stop being measured in hours and start being measured in years. Proxima Centauri, the nearest star beyond our own sun, sits 4.24 light-years away. Read that phrase again, slowly, because it contains the entire argument of tonight's program compressed into a single unit of measurement. A light-year is not a unit of distance dressed up to sound impressive. It is, quite literally, a unit of delay. It tells you exactly how far behind the present moment you are the instant you look at that star. When you look at Proxima Centauri on a clear night, assuming you had a telescope powerful enough to actually resolve it, you would not be seeing it as it exists right now. You would be seeing it exactly as it existed 4 years and 3 months ago. Whatever is happening on or around that star at this exact moment, you will not know about it, cannot know about it, for another 4 years and 3 months, no matter what you do, no matter what technology you build, no matter how badly you want to know sooner. This is where the prison stops being an inconvenience and becomes something closer to an absolute structural feature of your relationship with the rest of the universe. If a civilization existed on a hypothetical world orbiting Proxima Centauri, and they sent a message toward Earth today, the absolute earliest we could possibly receive it, traveling at the maximum speed the universe allows, is 4 years and 3 months from now. If we then wanted to respond, our reply wouldn't reach them for another 4 years and 3 months after that, A single question and a single answer, the most basic possible exchange between two civilizations, would require a minimum of 8.5 years to complete. And that's assuming both sides are transmitting continuously, listening constantly, and perfectly aligned in their timing. Real conversation, the back-and-forth rhythm we take completely for granted in every relationship we've ever had, becomes structurally, physically impossible across this kind of distance. Not difficult, not expensive, impossible, in the same sense that walking north from the North Pole is impossible, because the geometry of the situation itself forbids it, regardless of how skilled or determined you are. And Proxima Centauri, remember, is the closest star that exists anywhere in the universe. Every other star you have ever looked at, every point of light in the night sky, sits behind an even larger version of this exact same wall. Sirius, the brightest star in Earth's night sky, sits 8.6 light-years away, meaning the light entering your eye right now left that star 8.5 years ago. Everything that has happened in your life over the past 8.5 years, every relationship that began or ended, every year that quietly passed, Sirius has no knowledge of any of it, because the light-carrying information about what you've been doing hasn't reached it yet, and won't for years to come. And by the time it does, you will have already lived through years more that it also won't know about until its own separate delay finally catches up. Let's talk about what this actually does to the very concept of now, because in ordinary daily life, we treat now as an obvious, self-evident thing. Right now, you're reading or listening to this sentence. Right now, the sun is shining. Right now, somewhere on the other side of the planet, someone is asleep. We use the word constantly, effortlessly, as though it describes a single universal moment shared by everyone and everything everywhere. Einstein's theory of special relativity revealed that this intuition, comfortable as it feels, is not actually how the universe works. There is no universal now. There is no single, shared present moment that applies equally to you, to the Sun, to Proxima Centauri, and to a galaxy 2.5 million light-years away. Each of these things exists inside its own local now, and the only way any information from one now can ever reach another is by traveling at maximum at the speed of light, carrying an ever larger delay the farther it has to go. This isn't merely a practical inconvenience caused by our current level of technology. It is a fundamental feature of how causality itself operates within the structure of space-time. Two events separated by enough distance and too little time literally cannot influence each other at all, because no signal, no force, no information of any kind could possibly travel between them fast enough to connect them. Physicists call this being outside each other's light cone, a technical way of describing exactly the prison we've been building throughout tonight's program. A boundary expanding outward from every point in the universe at the speed of light, beyond which that point simply cannot affect or be affected by anything at all, for as long as the delay imposed by distance remains unresolved. Here's a way to feel this, rather than just understand it intellectually. Consider the sun, the single most familiar object in our entire sky, the thing that defines day and night, warms our planet, and has been rising and setting over human heads for the entirety of our species' existence. The light leaving the sun's surface takes about 8 minutes and 20 seconds to reach your eyes. This means that every single time you have ever looked at the sun in your entire life, you have never once seen it as it actually exists in the present moment. You have always been looking at a slightly outdated sun, a sun as it existed 8 minutes and 20 seconds earlier. If the sun somehow impossibly stopped shining this very instant, right now, as you're reading this sentence, you would have no way of knowing. The sky would remain exactly as bright as it currently appears. The warmth on your skin would remain unchanged. Every process on Earth that depends on sunlight would continue completely undisturbed for a little over 8 minutes, while you unknowingly lived inside a solar system whose sun had already gone dark, simply because the information hadn't caught up to you yet. You would be, for those 8 minutes, a prisoner of the past, going about your entire day without any way of knowing the single most important object in your sky no longer existed. Now stretch this same idea out across the true scale of the galaxy, and the walls of the prison start to feel less like an inconvenience and more like an entire architecture built specifically to keep every one of us permanently sealed away from the true present tense of the universe around us. The center of our own galaxy, home to the supermassive black hole known as Sagittarius A, sits roughly 26,000 light-years away. When the Event Horizon Telescope collaboration released the first-ever direct image of that black hole in 2022, every scientist involved understood implicitly that they were not photographing the galactic center as it currently exists. They were photographing it as it existed 26,000 years ago, when the last ice age was still gripping the planet, when early humans were painting animals onto cave walls in what is now France and Spain, long before the invention of agriculture, long before the earliest cities, long before written language of any kind existed anywhere on Earth. The light carrying that image had already been traveling for the entire span of recorded human civilization several times over before it finally reached our detectors and became, at long last, a photograph. Whatever Sagittarius A is doing right now, at this exact moment, we will not know for another 26,000 years, at absolute minimum. And that is only true if whatever information we're waiting for happens to be traveling toward us at the speed of light in the first place. If it isn't headed in our direction at all, we may never know, not in 26,000 years, not ever. The galactic center could undergo some dramatic, catastrophic transformation this very instant, and every human being alive today, and every human being who will ever live for the next 26 millennia would have absolutely no way of knowing, would continue looking up at a serene, unchanged night sky, entirely unaware that the actual, current state of the object they were looking at bore no resemblance whatsoever to the ancient light still quietly arriving in their telescopes. This is the honest, unsettling scale of the prison the speed of light has built around us. It isn't confined to deep space, to black holes, to events millions of years in the past. It applies with the exact same mathematical certainty to your neighbor's porch light, to the moon, to your own reflection in a mirror, at every distance, at every scale, without exception. differing only in how large the delay happens to be. The universe simply does not offer a now that spans more than a single point in space at a time. Everything beyond that single point, no matter how close or how far, exists for you only as history, delivered on a schedule set entirely by distance, with no possibility of ever speeding up the delivery, no matter how important the information, no matter how badly you need to know sooner. Let's talk about Andromeda, our nearest large galactic neighbor, because it offers one of the clearest, most viscerally strange demonstrations of exactly how deep this prison actually runs. Andromeda sits about 2.5 million light-years away, and it happens to be the single most distant object the unaided human eye can see, appearing on a sufficiently dark night as a faint, elongated smudge of light in the northern sky. When you look at that smudge, the light entering your eye left Andromeda 2.5 million years ago, before Homo sapiens existed in anything resembling our current form, before our species had developed language, tools, or fire, back when our most distant ancestors were still adapting to life on the African savanna. That light has been traveling uninterrupted for the entire span of human evolutionary history, and it is only now, tonight, arriving at your particular eye, at this particular moment, having crossed 2.5 million years of empty, expanding space to get here. Here's the detail that should genuinely stop you in your tracks. Andromeda and the Milky Way are currently approaching each other, drawn together by mutual gravity at roughly 270,000 miles per hour. And astronomers have calculated that in approximately 4.5 billion years, the two galaxies will collide and begin a slow multi-billion-year process of merging into a single, larger galaxy. That calculation, precise as it is, describes something that is already, in a sense, out of date the moment it's made, because it's based on light that is 2.5 million years old. We are calculating the future of a galaxy using information from its deep past, information that, while remarkably reliable given how slowly galactic-scale processes actually unfold, still represents our only possible window into a place we can never observe in real time, no matter how sophisticated our instruments eventually become. This is worth sitting with because it reveals something important about the actual nature of astronomy as a discipline. Every single observation ever made of an object beyond our immediate cosmic neighborhood is not a snapshot of the present. It is a fragment of history, arriving on a delay determined entirely by distance, and every conclusion astronomers draw about the current state of the universe is technically always a conclusion about its past state, extrapolated forward using our understanding of physical laws that we assume reasonably but never with absolute certainty continue to hold true in whatever now actually exists at that distant location, wherever and whenever that now might actually be. We do not study the universe as it is. We study the universe as it was, layer after layer after layer, stacked outward in every direction, and we build our entire picture of present-day reality by inference, never by direct observation, because direct observation of the present beyond our own immediate location is something the speed of light makes categorically, permanently impossible. Now let's push this idea to its absolute breaking point, out to the very edge of what we can observe at all. The observable universe, the total volume of space from which light has had enough time to reach us since the Big Bang, spans roughly 93 billion light-years in diameter, and within it, astronomers estimate there are approximately 2 trillion galaxies. The most distant galaxies we have ever imaged, using instruments like the Hubble Space Telescope and the James Webb Space Telescope, show light that left its source more than 13 billion years ago, when the universe itself was less than 1 billion years old, still in its earliest, most chaotic infancy, filled with small, irregular, violently star-forming structures that bear almost no resemblance to the mature spiral and elliptical galaxies that fill the sky today. When we look at those images, we are not looking at galaxies as they currently exist. In fact, given that the universe has continued expanding for the entire 13 billion years since that light was emitted, those same galaxies, if they still exist in any recognizable form at all, are now separated from us by a much greater distance than the light travel time alone would suggest. Some of them likely already having drifted, carried by the expansion of space itself, beyond the boundary from which their light could ever reach us again. We are looking at ancient photographs of places that, in their current form, we may never be able to observe again. Layered one on top of another, the deeper we look, the further back in time the layer extends, an entire visual archive of cosmic history spread out across the sky, readable only because light happens to have a fixed, finite, unbreakable speed, and every single layer of that archive represents a now we are permanently, structurally forbidden from ever directly witnessing. This is, I think, the moment where the phrase real-time prison stops being a clever turn of words and starts describing something close to the literal architecture of existence itself. You are not merely far away from the edge of the observable universe. You are separated from its actual current state by 13 billion years of accumulated delay, a delay that cannot be shortened, cannot be bypassed, cannot be solved by any amount of future technological progress, because the delay isn't a limitation of your equipment, it's a limitation of the medium information travels through, the very fabric of space-time, and no version of human ingenuity, however advanced, gets to negotiate with the actual structure of the universe. The prison doesn't have a warden you can appeal to. It doesn't have rules that bend under sufficiently clever engineering. It has exactly one rule: unbending, absolute, and universal. Nothing, including information, including knowledge, including the very concept of now, travels faster than light. Everything else in tonight's entire program is simply that one rule, expressed at different scales. Let's go a layer deeper into the physics itself, because there's an aspect of Einstein's relativity that makes this prison even stranger than simple delay. Something called the relativity of simultaneity. It's one thing to say that information takes time to travel, and that therefore you're always looking at the past. It's another, much stranger thing to say that the very question of what counts as at the same time doesn't actually have a single, universally agreed-upon answer at all, even in principle, even with perfect technology, even if delay weren't a factor whatsoever. Here's the idea, stripped down to its simplest form. Imagine two events happening at different locations in space. Whether those two events count as simultaneous, meaning happening at exactly the same moment, depends entirely on the motion of whoever is doing the observing. An observer moving in one direction might conclude the two events happened at exactly the same time. A different observer, moving at a different velocity, observing the exact same two events, might conclude that one happened noticeably before the other. Neither observer is wrong. Neither one has made a measurement error. They are both correct simultaneously in a universe where simultaneity itself simply isn't a fixed, absolute property of reality, the way our everyday intuition assumes it must be. This isn't a limitation of measurement. It is a fundamental feature of how space-time is actually structured, confirmed experimentally again and again over more than a century of physics. What this means, in the context of tonight's program, is that the prison we're describing isn't simply a matter of the information hasn't arrived yet, but there really is a single true now happening everywhere at once that we just can't access. There may not even be a single true now to access in the first place, not even in principle, not even for a hypothetical being with infinite patience and perfect instruments. The very concept of a universal present moment shared identically by every point in the cosmos appears to be something our brains invented to make sense of our own extremely local, extremely slow-moving daily experience. A convenient fiction that works perfectly well at the scale of a dinner table and completely breaks down the moment you try to stretch it across any meaningful cosmic distance. The prison isn't just built out of delay. It's built out of the fact that the very thing we're delayed in reaching, a single objective present moment shared across the universe, may not actually exist as a coherent concept at all once you look closely enough at the physics underlying it. This idea connects directly to something physicists call the light cone, a concept that gives the prison we're describing tonight an actual, precise mathematical shape. Picture yourself right now at this exact moment as a single point in space-time. From that point, imagine light radiating outward in every direction simultaneously, forming an ever-expanding sphere. Everything that sphere touches, as it grows outward at the speed of light, represents the absolute fastest that any information originating from you, right now, could ever possibly reach. This expanding sphere is called your future light cone, and it represents the complete boundary of everything you could ever possibly influence, communicate with, or affect for the rest of time. There is also a second cone pointing backward instead of forward, called your past light cone, representing every event anywhere in the universe whose light has had enough time to reach you by this exact moment. Everything you can currently see, everything you can currently know about, everything that has ever influenced you in any way lies somewhere inside that backward-pointing cone. And here is the crucial, prison-defining detail. Anything outside both of these cones, anything too far away for light to have reached you yet, and too far away for any signal you send now to ever reach it in time to matter, is called, with a bluntness physicists rarely allow themselves, causally disconnected from you. It cannot affect you. You cannot affect it. For all practical and even theoretical purposes, it might as well not exist, at least as far as any possible relationship between the two of you is concerned, for as long as that causal disconnection persists. This is not a metaphor. It is a precise, mathematically rigorous description of how causality actually operates within the structure of space-time. And it means that at every single moment of your life, the overwhelming majority of the universe, essentially all of it, beyond a rapidly shrinking, ever-changing local neighborhood, exists entirely outside your light cone, permanently unreachable, permanently unknowable in real time, permanently separated from you not by mere distance, but by the actual causal architecture of reality itself. You are not simply far away from most of the universe. You are, in the strictest technical sense, causally sealed off from it, existing inside a bubble whose boundary expands outward at exactly the speed of light and not 1 mile per hour faster. A bubble that defines, with total precision, the entire physical shape of the prison this program is named after. Now, let's talk about what this actually means for the search for other intelligent life, because this is where the real-time prison stops being an abstract physics lesson and starts becoming one of the most quietly devastating ideas in all of modern astronomy. We've been broadcasting radio signals into space, first unintentionally and later deliberately, since the early 20th century, forming what astronomers call our radio bubble, the accumulated sphere of every broadcast, every television transmission, every deliberate message we've ever sent outward, expanding at the speed of light in every direction since roughly the 1920s. That bubble is currently only about 240 light-years in diameter, a genuinely tiny fraction of our own galaxy's 100,000 light-year span. Consider what this means for any hypothetical civilization listening from somewhere within our own galaxy. If they happen to sit within that 240 light-year bubble, they might, in principle, have detected some trace of our earliest radio transmissions. If they sit even slightly beyond it, they have received absolutely nothing from us, not one single signal, not because we haven't tried, but because the information simply hasn't had time to reach them yet, and won't for years or centuries or millennia to come, depending on the exact distance involved. And the reverse is exactly symmetrically true. If a civilization exists 1,000 light-years away, and they began broadcasting radio signals of their own 1,000 years ago, we would only just now be receiving their very first transmissions. If they started broadcasting 500 years ago, their signals haven't reached us yet at all, and won't for another 500 years, regardless of how advanced their technology has become in the meantime, regardless of how badly either of us might want to know the other exists. This is the deeper, more sobering explanation buried inside the famous Fermi paradox, the question first posed informally by physicist Enrico Fermi in 1950, asking why, given the vast number of stars and potentially habitable planets in our galaxy, we haven't detected any clear evidence of other technological civilizations. The honest answer may have very little to do with whether such civilizations exist, and everything to do with the real-time prison the speed of light imposes on absolutely everyone, everywhere, without exception. Two civilizations could exist simultaneously, separated by 1,000 light-years, both actively broadcasting, both actively listening and still remain completely unaware of each other for the entire durations of both their existences, simply because the light carrying the evidence hasn't had enough time to cross the gap yet. The universe could be teeming with intelligent life, and the silence we observe when we point our telescopes outward and listen might not be evidence of an empty cosmos at all. It might simply be evidence of a prison so effective that it can hide an entire galaxy's worth of neighbors from each other indefinitely, using nothing more exotic than the ordinary, unavoidable passage of light travel time. The Drake equation, formulated by astronomer Frank Drake in 1961, attempts to estimate the number of currently detectable civilizations in our galaxy by multiplying together a series of probabilities: the rate of star formation, the fraction of stars with planets, the fraction of planets capable of supporting life, the fraction where life actually develops, the fraction where that life develops intelligence, the fraction of intelligent species that go on to develop detectable technology, and finally, the average lifespan of a technological civilization once it emerges. Even under reasonably optimistic assumptions for each of these factors, the equation suggests that if detectable civilizations exist at all, they might be separated from each other by an average of somewhere around 1,000 light years or more. Now, combine that estimate with everything we've established tonight about the real-time prison, and a genuinely strange picture starts to emerge. 1,000 light years means a minimum 2,000-year round trip for a single question and a single answer, assuming both civilizations happen to still exist by the time the reply finally arrives, which is itself a significant assumption, since the same equation that estimates the distance between civilizations also estimates, based on our own historical track record with nuclear weapons, climate instability, and other existential risks, that the average technological civilization may not actually survive for anywhere near that long. It becomes entirely possible, even likely, that any given attempt at interstellar communication is really a conversation with a civilization's own ghost, a signal sent by a society that has already collapsed, transformed beyond recognition, or gone extinct by the time any response could possibly arrive. The reply crossing an empty gulf toward a listener who no longer exists to hear it. This is worth sitting with because it reframes the entire search for extraterrestrial intelligence in a much more sobering light. We are not simply searching for evidence that we are not alone. We are searching within a communication system so fundamentally broken by distance and delay that even a successful detection, even an unambiguous, confirmed signal from another civilization, might represent nothing more than an echo of something that no longer exists, arriving at a destination, us, that might itself no longer exist in any recognizable form by the time a reply could ever make its way back. The real-time prison doesn't just prevent conversation. In its most extreme cases, it can turn even successful contact into something closer to archaeology, a message from the dead, received by the living, with no possibility of either side ever actually meeting the other in any shared, mutual, present moment. Now let's talk about whether the prison is getting worse over time, because, unfortunately, it is, and the reason has nothing to do with the speed of light itself, which remains permanently, unchangeably fixed, and everything to do with the space that light has to cross. In 1998, two independent teams of astronomers studying a particular class of stellar explosion called type Ia supernovae discovered something that upended a century of assumptions about the universe. Its expansion is not slowing down under the pull of gravity, as everyone had expected. It is accelerating, driven by a mysterious force astronomers named dark energy, which current measurements suggest makes up roughly 68% of the total energy content of the universe, despite the fact that we still don't have a fully satisfying explanation for what it actually is. Here is the consequence that makes our real-time prison actively expand with every passing year. Because the universe's expansion is accelerating, there exists a distance, currently estimated at roughly 16 billion light-years, beyond which galaxies are receding from us faster than light itself, can cross the growing space between us. This doesn't mean those galaxies are physically moving faster than light through space, which relativity forbids. It means space itself is expanding between us and them at a rate faster than light can outpace. So any light they emit toward us right now will simply never arrive, ever, for the remainder of cosmic history. Those galaxies aren't merely delayed. They are permanently, irreversibly sealed outside our light cone, already lost to us in every meaningful sense, regardless of what happens next. And this cosmic horizon isn't fixed in place. As the expansion continues accelerating, it steadily creeps closer to us, meaning galaxies currently just within our light cone, currently still capable of one day sending us information, will gradually cross that threshold and become permanently unreachable, their light stretched into longer and longer wavelengths as it fights against the accelerating expansion, fading first into infrared, then microwave, then radio frequencies too faint to ever detect, before disappearing from our accessible universe entirely, not because anything happened to them, but because the space between us and them expanded faster than their light could ever hope to cross it. The real-time prison we've been describing all night isn't a static, unchanging cell. Its walls are actively closing in, permanently, irreversibly, at a measurable rate, meaning the volume of universe we could ever theoretically receive information from, let alone visit, shrinks a little more with every year that passes, a process that will continue for the rest of cosmic history, regardless of anything humanity does or builds or discovers. Run this idea forward far enough, and the picture becomes almost unbearably stark. In roughly 100 billion years, if dark energy continues behaving the way our current models predict, essentially every galaxy currently visible to us will have been carried beyond the cosmic horizon by the relentless acceleration of space, disappearing permanently from any future observer's sky. An astronomer, living at that point in cosmic history, looking outward with instruments as good as or better than our own, would see only the merged remnant of the Milky Way and Andromeda, our own local group's final product, surrounded by an empty, silent, expanding darkness stretching in every direction. They would have absolutely no evidence that 2 trillion galaxies, an entire observable cosmic web of filaments and voids and superclusters, had ever existed at all. They would construct their entire understanding of the universe from a radically incomplete, badly mistaken picture, and they would have no way of knowing it was mistaken, because the real-time prison would have, by then, fully and permanently closed around them, erasing the evidence of everything beyond their own tiny, isolated cosmic neighborhood. We happen to exist during a strange, narrow, genuinely fortunate window in cosmic history, one where the expansion of the universe hasn't yet erased the evidence of its own vast structure. We can still see 2 trillion galaxies. We can still trace the cosmic web. We can still measure the afterglow of the Big Bang itself, spread faintly across the entire sky. That window will not remain open forever. It is, on a cosmological time scale, an almost impossibly brief flash of visibility, one that our own species happens to exist within, purely by the accident of when, in the 14-billion-year history of the universe, we happen to evolve enough intelligence to build a telescope and look up. This detail deserves to sit uncomfortably alongside everything else we've discussed tonight, because it means the real-time prison isn't simply a permanent, static feature of the universe that has always existed in exactly its current form and always will. It is a prison actively under construction, its walls slowly, irreversibly closing, and the version of the universe we can currently see, study, and measure represents quite literally one of the last remaining glimpses any civilization anywhere will ever get of the full scope of what actually exists. We are not just prisoners of the speed of light. We are prisoners caught in the brief closing window before the cell becomes permanently, completely sealed, watching the walls draw inward in real time, measured across the unimaginable span of billions of years, but measurable nonetheless, happening right now at this very moment, whether we notice it or not. It's worth pausing here to ask whether there's any loophole at all, any way information could ever travel faster than light, breaking free of the prison rather than simply serving out its sentence more efficiently. And the honest answer, backed by more than a century of increasingly precise experimental testing, is no, though the universe does contain one genuinely strange phenomenon that makes people think, briefly, that it might have found one: quantum entanglement. When 2 particles become entangled, a quantum state links them together in such a way that measuring a property of one particle instantly correlates with the corresponding property of the other, even if the 2 particles are separated by enormous distances, a phenomenon Einstein himself famously and dismissively called spooky action at a distance, because it seemed to violate everything relativity had established about the impossibility of faster-than-light influence. Experiments have confirmed entanglement is real, repeatedly, rigorously, at distances spanning hundreds of miles. But here is the crucial detail that closes the apparent loophole completely. The correlation between entangled particles cannot actually be used to send usable information faster than light. The outcome of any individual measurement is genuinely random, and it's only when you compare notes between the 2 locations, a comparison that itself requires sending information through completely ordinary means, at or below the speed of light, that the correlation becomes apparent at all. You cannot use entanglement to send a message. You can only use it to confirm, after the fact, using conventional communication, that a correlation existed. The spooky action is real. The escape route it seems to promise is not. This detail matters enormously for tonight's program because it closes off what might otherwise seem like the most promising possible exception to everything we've described. If even the strangest, most genuinely bizarre phenomenon quantum physics has ever discovered still cannot break the prison's central rule, still cannot deliver usable information from one point in space to another, faster than light allows, then the prison truly is as complete and as inescapable as it appears. There is no quantum backdoor. There is no clever trick hiding somewhere in the deeper mathematics of physics that lets information slip past the speed limit unnoticed. Every single test, every single experiment, every single theoretical framework physicists have developed over more than a century points toward the exact same unwavering conclusion. Nothing, under any circumstances, by any mechanism we have ever discovered or seriously proposed, moves information faster than light, and that includes the very fabric of quantum mechanics itself, the branch of physics most famous for behaving in ways that violate ordinary human intuition at every other turn. Let's talk about the one genuine, scientifically legitimate exception to everything we've discussed tonight. The one narrow loophole that doesn't actually let anyone break the speed limit, but does let a traveler experience the passage of time differently than everyone they left behind. Time dilation, a direct and experimentally confirmed consequence of Einstein's special relativity. The faster an object moves relative to an observer, the slower time passes for that object. From the observer's frame of reference, this isn't speculation. It has been measured directly and repeatedly, using atomic clocks flown aboard airplanes, using GPS satellites that must constantly correct for it to remain accurate, using particles accelerated to near light speed in laboratories here on Earth. Here's what this means practically for anyone attempting to escape the real-time prison through sheer velocity. A hypothetical crew traveling at a large fraction of the speed of light toward a distant star would, from their own onboard perspective, experience the journey passing much more quickly than an observer watching from Earth. In principle, a traveler moving at 99.9% of light speed could cross a genuinely enormous distance while experiencing only a small fraction of the elapsed time that passes for everyone left behind on Earth. This sounds at first glance like exactly the escape hatch we've been searching for all night, a way to personally outrun the prison's walls, even if the information itself never technically exceeds the speed limit. But look closely at what this actually delivers, and the loophole reveals itself to be far narrower and far stranger than it first appears. Time dilation doesn't shrink the actual distance being crossed, and it doesn't speed up the light itself, or any communication sent back to Earth during the journey. It only changes how much subjective time the traveler personally experiences while everyone else continues experiencing the full uncompressed duration. A crew that experiences only a handful of years traveling toward a distant star might return, if a return trip is even possible, to find that decades or centuries have passed back home, their friends, their families, quite possibly their entire civilization, having aged forward into a future the travelers never got to live through themselves. Time dilation doesn't let you escape the prison. It lets you personally skip ahead within it, arriving in someone else's future while remaining, for everyone you left behind, permanently and irreversibly gone, present only as an outdated memory, exactly the same kind of delayed, backward-looking relationship that defines every single example we've explored throughout this entire program. Even the one loophole relativity offers turns out to be built from precisely the same material as the prison itself. There's a human history worth mentioning here, because it turns out our species has actually lived through smaller, less extreme versions of this exact same prison before, long before anyone understood the physics behind it. Consider letters carried by sailing ship across the Atlantic Ocean in the 17th and 18th centuries, a journey that could take anywhere from 6 weeks to several months, depending on winds, weather, and the particular route involved. A person writing home from a distant colony was, in a very real sense, writing to a version of their family that no longer existed by the time the letter was read, and receiving replies that described a version of home that had already changed by the time those replies were written. Marriages happened, children were born, people died, entire fortunes rose and fell, all while a single exchange of letters slowly made its way across an ocean, carrying news that was already outdated the moment ink touched paper. This delay shaped entire lives. Soldiers stationed overseas during long historical conflicts sometimes learned of the birth of their own children months after the fact, sometimes learning of a child's death before ever learning of their birth, the letters simply arriving out of order, carried by different ships on different schedules, no way to guarantee which piece of news would arrive first. Diplomatic negotiations conducted across oceans could result in wars being fought over decisions that had already been reversed by the time news of the reversal finally crossed the water. Entire battles taking place after peace had technically already been declared, simply because the information hadn't traveled fast enough to stop them. What's genuinely instructive about these historical examples is how completely they were eventually solved, not by philosophy or acceptance, but by pure engineering. The telegraph, and later the transatlantic cable, collapsed a delay of months down to a delay of minutes and eventually seconds, transforming what had once felt like a fundamental, permanent feature of long-distance relationships into a solved problem, a brief historical inconvenience rather than a lasting condition. This is precisely why so many people, understandably, assume the same thing will eventually happen to the delays we've spent this whole program describing, that some future breakthrough, some undiscovered technology, will eventually collapse the light speed delay the same way the telegraph collapsed the delay of sailing ships. But the comparison, however intuitive, breaks down at exactly the point where it matters most. The delay of a sailing ship was a limitation of the technology carrying the message. The delay imposed by the speed of light is a limitation of the maximum speed anything, including the very concept of information itself, is permitted to travel through the universe. One was a problem of engineering. The other is a problem of physics. And engineering, however brilliant, has never once in human history solved a problem that turned out to be physics instead. And yet, exactly as we found in our earlier exploration of cosmic distance, this prison has not stopped human beings from reaching outward anyway, using the one tool that actually can cross these gulfs: patient, careful observation. Gravitational waves, ripples in the fabric of space-time itself, predicted by Einstein in 1916 and first directly detected in 2015 by the twin LIGO observatories, travel at exactly the speed of light, meaning they carry exactly the same kind of delay as everything else we've discussed tonight, arriving from events that happened millions or billions of years ago, describing black hole mergers and neutron-star collisions as they existed deep in the past, rather than as they exist now. But the mere fact that we can detect them at all, ripples smaller than the width of a single proton by the time they reach Earth after crossing over 1 billion light-years of space, represents an extraordinary act of reaching across the very prison walls we've spent this program describing. The cosmic microwave background offers perhaps the most striking example of all. This faint microwave radiation filling the entire sky uniformly in every direction is the oldest light in the universe. The thermal afterglow of the Big Bang itself, emitted roughly 380,000 years after the universe began, when it had cooled enough for the first neutral atoms to form and light to travel freely for the first time. That light has been traveling uninterrupted for nearly the entire 14-billion-year history of the universe, and it arrives at our detectors today, right now, carrying an almost unimaginably detailed snapshot of what the universe looked like when it was less than 100,000th of its current age. We are not merely trapped behind a wall of delay. We have learned to read that wall like a book, extracting the age, the geometry, and the composition of the entire universe from the precise pattern of tiny temperature variations embedded in light that is nearly as old as time itself. This doesn't undo anything we've established tonight. The prison is real. The delay is permanent. The present tense of almost everything beyond our own tiny corner of space remains, and will always remain, categorically inaccessible to us. But within that prison, human beings have built instruments capable of reading history directly out of ancient light, capable of detecting ripples in space-time from collisions that occurred before our own planet had fully formed, capable of calculating the age and shape and composition of the entire universe using nothing more than the patient, careful study of light that left its source before any of us were born, before civilization existed, before, in some cases, our own solar system had even finished coalescing out of the gas and dust that would eventually become the sun and the 8 planets orbiting it. We cannot escape the walls, but we have become extraordinarily good at reading what's written on them. There's a strange, almost paradoxical comfort buried inside this prison, one worth sitting with before we move toward tonight's close, and it has to do with protection rather than confinement, because the speed of light doesn't just delay information from reaching us, it also delays danger, and in a universe filled with genuinely catastrophic events, that delay might be one of the most quietly important safety features we have. Consider a gamma-ray burst. one of the most violent energetic events known to occur anywhere in the universe, typically produced by the collapse of a massive star or the merger of two neutron stars, releasing in a matter of seconds more energy than our sun will produce across its entire multi-billion-year lifetime. If a gamma-ray burst occurred close enough to Earth and happened to be aimed directly at us, the resulting radiation could strip away a significant portion of our atmospheric ozone layer, triggering a mass extinction event. Some researchers have even proposed that a nearby gamma-ray burst may have contributed to a mass extinction in Earth's deep past, roughly 440 million years ago, though the evidence remains debated. Here's the detail that matters for tonight's discussion because these events are so distant, occurring predominantly in other galaxies or in distant regions of our own. The light and radiation from them take so long to reach us that we would, at minimum, have some structural buffer of time and distance between ourselves and any single catastrophic event. A buffer created entirely by the very same speed limit that otherwise traps us in permanent informational isolation. The same logic applies at a smaller, more personal scale, too. Every hazard in the universe, every collision, every explosion, every catastrophic event happening anywhere beyond our own immediate neighborhood announces itself to us only after a delay proportional to its distance, which means, in a strange, almost comforting way, that danger itself is subject to exactly the same walls that trap our knowledge and our travel. We are protected from instantaneous cosmic catastrophe by the exact same mechanism that prevents us from having a real-time conversation with anyone beyond our own solar system. The prison that keeps us from reaching outward also, quite literally, buys us time. Every single time something dangerous happens anywhere in the universe, because that danger, too, is bound by the same absolute speed limit as everything else, unable to reach us instantaneously, no matter how close or how violent the event actually is. Let's bring this back down to something achingly personal, because everything we've discussed tonight, every galaxy, every black hole, every light year of delay, applies with exactly the same mathematical certainty to the smallest, most intimate distances in your own life, not just the vast cosmic ones. Think about the last time you looked at an old photograph or watched an old home video of someone you love who has since passed away. In a strange, almost literal sense, you were doing the exact same thing an astronomer does when they look at the light from a star that burned out millions of years ago. You were looking at light captured and preserved, showing you a version of a person exactly as they existed in a specific past moment, a moment that, by the time you're viewing it, no longer exists anywhere in the present, a moment you can revisit endlessly but never actually return to, never actually inhabit again, no matter how many times you press play. This is, I think, one of the most quietly profound consequences of everything we've discussed tonight. The realization that the relationship between distance and delay isn't only a cosmic phenomenon, confined to telescopes and spacecraft and light years. It's the exact same relationship that governs memory itself, governs every photograph, every recording, every letter, every message any of us has ever sent or received from someone we love. Every memory you hold of another person is, in its own way, exactly like starlight, a delayed signal from a now that has already passed, carrying information about a version of reality that existed once, briefly, and then continued changing into something you weren't present to witness. The same way Andromeda has continued evolving, unseen by us. For the entire 2.5 million years, its light has spent traveling toward our eyes. We live our entire lives surrounded by exactly this kind of delay at every scale, from the 8-minute lag of sunlight to the decades-long lag of an old family photograph to the millions of years separating us from the light of a distant galaxy. And somehow, despite understanding almost none of the physics behind it, human beings have always intuitively grasped the emotional shape of this exact same idea. We already know in our bones, long before anyone explains the speed of light to us, that the past is a place we can look at but never touch, a place whose light keeps arriving long after the moment itself has already moved on without us. Tonight's entire program has simply been an extended, precise, scientifically rigorous version of something the human heart already understood the very first time someone missed a person who was gone. Let's pull everything we've covered tonight back together, because scattered across an hour of conversation, these numbers can start to blur, and hearing them stacked one after another in sequence is the only way to really feel the full weight of the prison we've been describing. A friend across the table, about 6 billionths of a second behind the present. The moon, 1¼ seconds. The sun, 8 minutes and 20 seconds, meaning you have never once in your entire life seen it as it actually exists right now. Mars, at closest approach, about 3 minutes, enough to make real-time conversation with a future Martian colony permanently, structurally impossible. Neptune, about 4 hours. Voyager 1, our most distant spacecraft, over 22 hours, turning even the simplest command into a nearly 2-day exchange. Proxima Centauri, the nearest star beyond our own sun, 4 years and 3 months, meaning any potential neighbor there is already living in a now we cannot access for years, no matter what we do. Sirius, 8.5 years, the center of our own galaxy, 26,000 years, meaning the black hole photographed by the Event Horizon Telescope was seen exactly as it looked before human civilization began. Andromeda, the most distant object visible to the naked human eye, 2.5 million years older than our own species. The most distant galaxies ever imaged, over 13 billion years, nearly the entire age of the universe itself, and beyond a certain horizon, currently around 16 billion light-years and creeping steadily closer with every passing year as dark energy accelerates the universe's expansion, the delay stops being merely enormous and becomes permanent, absolute, a one-way door that closes forever, sealing certain regions of the universe outside our light cone for the remainder of cosmic history. Every single one of these numbers describes the exact same phenomenon, appearing at every possible scale, from the width of a dinner table to the edge of the observable universe. There is no version of now that includes anything beyond your own immediate location. There never has been, and there never will be, no matter how advanced our technology eventually becomes, because the limitation isn't a matter of engineering. It's a matter of the actual, unbending, mathematically precise structure of space-time itself. The same structure that gives the universe its shape, its causality, its very sense of past, present, and future. The speed of light doesn't just limit how fast you can travel. It defines, with total precision, exactly how much of the universe you are allowed to know about in real time, and that number, for every single one of us, without exception, is depressingly, permanently, beautifully small. So what do we actually do with this? Once we've fully accepted it, once we stop looking for the loophole and simply sit with the fact that the loophole doesn't exist, I think the honest answer is something quieter and more useful than despair. And it starts with a small but important shift in how we think about the word now itself. If a truly universal shared present moment doesn't actually exist in any meaningful sense beyond our own immediate location, then perhaps the more honest way to think about your life isn't as a single point moving forward through a universal timeline shared by everyone and everything, but as a small, local bubble of now, a light cone of your own, expanding outward at the speed of light in every direction, encompassing everyone and everything you could ever possibly reach, influence, or know about in real time. That bubble is small, cosmically speaking, absurdly small, but it is also, and this is the important part, entirely, completely yours. It contains your family, your friends, your home, your city, your planet, every relationship and every experience that has ever actually mattered to you in the specific, immediate, textured way that only real-time presence allows. Everything outside that bubble, every distant star, every far-off galaxy, every hypothetical civilization we'll never speak with in either of our lifetimes, was never actually going to be part of your now, in any meaningful sense anyway. Prison or no prison, speed of light or not. This reframing doesn't make the prison walls disappear. They are still there, still absolute, still governed by the exact same unbending physics we've spent this whole program describing. But it does something almost as valuable. It clarifies exactly where the walls actually sit, and exactly how much genuinely reachable, genuinely real-time, genuinely present tense life exists inside them. The tragedy of the real-time prison was never that it kept us from Andromeda or from the galactic center or from a hypothetical civilization 1,000 light years away, because none of those things were ever going to be part of anyone's actual lived real-time present moment, regardless of how fast light happened to travel. The prison simply reveals, with mathematical precision, something that was always quietly true. Your real, actual, present tense life has always been small, local, and immediate, built from the handful of people and places close enough to share your light cone with you, and that smallness was never a limitation imposed by the speed of light. It is, and always has been, simply what a present moment actually is. There's a particular kind of gratitude available inside this idea, one that only becomes visible once you've fully absorbed just how vast the prison actually is. Because if the overwhelming majority of the universe is permanently sealed away from your real-time present moment, existing for you only as delayed light, ancient photographs, and inference, then the small handful of things that do exist inside your light cone, the people you can actually call on the phone and hear respond within a fraction of a second, the friend sitting across the table whose expression changes in genuine, real time as you speak, the family member you can hug and feel respond to your embrace in the same instant you offer it, become almost impossibly precious by comparison. Real-time presence, it turns out, is not the default condition of the universe. It is an extraordinarily rare, extraordinarily local privilege, available only within an almost vanishingly small bubble around wherever you happen to be standing. And every relationship you have that actually falls inside that bubble is, in the most literal physical sense, one of the rarest things the universe has to offer. Think about what it actually means, physically, to hold someone's hand. In that exact moment, you are experiencing something the vast majority of the universe will never, ever allow. 2 points in space-time, close enough together that the delay between them is smaller than either of you could ever consciously perceive, sharing, as close to genuinely as physics permits, the same present moment, the same now. Every star in the night sky, every galaxy, every black hole, every civilization that might or might not exist somewhere out in that vast, expanding darkness is permanently denied this exact experience with every other point in the universe beyond its own immediate neighborhood. You are not. Not with the people close enough to actually be present with you. That is not a small thing. That is, when you actually understand the scale of everything we've discussed tonight, one of the rarest, most genuinely remarkable privileges the structure of the universe allows any 2 points in space-time to share with each other, and it is available to you freely, constantly, every single time you're in a room with someone you love. And yet, exactly as we discovered in exploring the sheer scale of cosmic distance in an earlier program, human beings have never simply accepted a wall without first trying to understand every inch of it, and the study of light speed delay itself, the very thing that traps us, has become one of the most powerful tools we've ever built for understanding the universe we're trapped inside of. Every single measurement of cosmic distance, every calculation of a galaxy's age, every reconstruction of the early universe's conditions relies directly on the fact that light takes time to travel, that the delay is precise, measurable, and consistent, allowing scientists to essentially read a clock built into the fabric of the cosmos itself. The prison, in other words, isn't simply a limitation. It is also, paradoxically, the exact mechanism that makes cosmology possible at all. Without the fixed, unbending speed of light, we would have no way to determine the age of the universe, no way to trace the history of galaxy formation, no way to reconstruct the very early moments after the Big Bang from the light still arriving today. The wall and the window turn out to be made of exactly the same material. This is worth remembering the next time the scale of everything we've discussed tonight starts to feel discouraging. Every constraint we've described, the impossibility of real-time conversation with Mars, the 26,000-year delay separating us from our own galactic center, the permanent, ever-growing cosmic horizon beyond which entire galaxies vanish from our reach forever, is also, simultaneously, the exact mechanism that has allowed a species confined to a single small planet to calculate the age of the universe to within a fraction of a percent, to photograph the shadow of a black hole 26,000 light-years away, to detect the faint thermal afterglow of an explosion that happened nearly 14 billion years ago, and to understand, with genuine scientific confidence, almost the entire history of everything that has ever existed. The prison didn't just trap us. It also, in a strange, roundabout, deeply human way, taught us almost everything we currently know. There's one more idea worth sitting with before we head toward tonight's close, and it comes from a strange, almost dizzying thought experiment that physicists occasionally use to illustrate just how deeply this prison actually reaches. Imagine for a moment that somewhere out there, in some distant corner of the universe, an advanced civilization has actually solved every engineering problem standing between them and interstellar travel. Imagine they've built ships capable of crossing thousands of light-years, that they've mastered radiation shielding, generation-spanning life support, every physical challenge we discussed at length in an earlier program about the difficulty of interstellar distance. Even that hypothetical maximally advanced civilization would still be bound by exactly the same real-time prison we've spent tonight describing, because faster-than-light travel and faster-than-light communication are not separate problems with separate solutions. They are the exact same problem, governed by the exact same unbending speed limit, appearing in two different disguises. A ship traveling at 99% of the speed of light is still bound by the speed of light. A radio signal sent alongside that ship is still bound by the speed of light. No matter how advanced the civilization, no matter how solved every engineering challenge becomes, the fundamental architecture of causality itself, the light cone, the relativity of simultaneity, the absolute impossibility of information outrunning light, remains exactly, precisely, unchangeably in place. This is perhaps the single most important thing to understand about the prison we've spent tonight exploring. It is not a technological problem awaiting a technological solution. The way crossing an ocean or crossing a continent eventually became solvable problems through better ships and better engines. It is a structural feature of reality itself, applying with exactly the same force to the most advanced hypothetical civilization anywhere in the universe as it applies to a single human being looking up at the night sky from their own backyard tonight. There is no version of technological progress, however extreme, however many thousands or millions of years into the future you imagine it, that ever escapes this particular wall. Every civilization that has ever existed or will ever exist anywhere in this vast universe, if it is bound by the same laws of physics we are, and every piece of evidence suggests those laws are genuinely universal, shares this exact same confinement, this exact same inability to ever truly know, in real time, anything beyond its own small, local, ever-expanding bubble of now. So let's step back now, all the way back, past the equations, past the light cones, past the 26,000-year delay to the center of our own galaxy, and sit with what all of this actually means for a single person, standing on a single planet, looking up at a single sky. You were born into a prison built out of the fastest thing in the universe, a prison whose walls are invisible precisely because they move at the exact speed your own senses use to perceive the world in the first place. You have never once in your entire life experienced the true current present tense of anything beyond your own immediate location. Not the sun, not the moon, not the person sitting across the room from you, though at that distance the delay is so small it might as well not exist. Every single thing you have ever seen, heard about, or learned regarding anything beyond your own skin has already happened, already finished, already moved on into whatever comes next by the time the information reached you. And yet, inside that prison, something remarkable happened anyway. A species evolved on a small, unremarkable planet, orbiting a completely ordinary star, and that species, without ever once experiencing a genuine, real-time view of anything beyond its own tiny cosmic neighborhood, managed to calculate the age of the universe, to measure the mass of black holes it will never visit, to detect ripples in space-time from collisions that happened before its own planet had finished forming, and to understand, with rigorous, hard-won scientific precision, almost the entire 14-billion-year history of everything that has ever existed. We did all of this while permanently, completely sealed inside our own light cone, unable to ever verify in real time whether any of it remained true the instant after we measured it. We built an entire civilization's worth of knowledge out of nothing but delayed light, old photographs of a universe that had already moved on, and we did it anyway, patiently, carefully, one careful observation at a time, because understanding the walls of your own prison in complete and exhaustive detail turns out to be one of the most worthwhile things a confined species can ever choose to do with its time. There's a small human-scale detail worth mentioning before we finally close, because it captures the emotional core of everything we've discussed tonight in a single physical object. Attached to both Voyager 1 and Voyager 2, bolted to the outside of each spacecraft before launch in 1977, is a gold-plated copper phonograph record, known as the Golden Record, containing greetings in 55 languages, samples of music from cultures across the entire planet, and images encoded in analog form depicting our biology, our mathematics, and our daily lives. The scientists who assembled it, led by astronomer Carl Sagan, understood the real-time prison better than almost anyone alive at the time. They knew that even if the record were somehow found by another civilization, thousands or tens of thousands of years from now, in some distant corner of the galaxy, the greeting inscribed on it would already be catastrophically out of date, a message from a version of humanity that would have long since changed beyond recognition by the time anyone ever heard it, addressed to a civilization whose own present tense, whatever it turned out to be, none of us would ever live to learn about. They built it anyway, not because the delay could be overcome, and not because the message would ever arrive in anything resembling real time, but because reaching outward, even across a gap you know you can never bridge in your own lifetime, even knowing the message will always be a message from the past, addressed to a future you will never witness, still seemed worth doing. That decision says something important about how a species that fully understands its own prison might choose to behave inside it, not by refusing to speak simply because no reply could ever arrive quickly enough to matter, but by speaking anyway, patiently, honestly, fully aware that every word sent outward is already a fossil the instant it leaves, and sending it regardless. Because somewhere, someday, however many thousands of years from now, another consciousness delayed by exactly the same walls we live behind might finally receive it and feel, if only for a moment, a little less alone inside a universe built entirely out of light that always arrives too late. It's also worth considering one final time whether the speed of light being exactly what it is, no faster and no slower, might actually be a kind of quiet mercy rather than purely a limitation. A universe where information traveled instantaneously across any distance would be a universe without delay, without the layered archive of history we've spent this entire program learning to read, without the protective buffer that keeps distant cosmic violence from reaching us the instant it occurs. It would also, more subtly, be a universe without genuine distance at all, in any meaningful sense, because a place you could know about instantly, communicate with instantly, and reach instantly is, for almost every practical purpose, no longer really a separate place at all. Some part of what makes a star, what makes a galaxy, what makes a distant civilization distant, depends entirely on the fact that reaching it costs something, that knowing about it costs time, that the universe maintains real separations between real places rather than collapsing everything into a single, flattened, instantaneous everywhere. The prison, in this framing, isn't simply an obstacle standing between us and the rest of the universe. It might be the very thing that allows the universe to have genuine parts at all, genuine distances, genuine individual places, each with their own local history, rather than one undifferentiated, instantaneously connected blur. This is speculation, admittedly more philosophy than physics, but it's the kind of speculation that feels earned after walking through everything else we've covered tonight. The speed of light didn't have to be exactly what it is. As far as our current physics can tell, it simply is, a fixed constant woven into the structure of the universe from its very first moments, and every single consequence we've explored tonight, every prison wall, every 26,000-year delay, every permanently sealed cosmic horizon follows directly and unavoidably from that one unchanging number. We didn't choose the walls. We were simply born inside them, the same way every star, every galaxy, and quite possibly every civilization anywhere in this vast universe was also born inside them. All of us serving out the exact same sentence at the exact same fixed rate for as long as the universe itself continues to exist. If you're wondering honestly whether any of tonight's physics should change how you plan your own life, the answer is probably not in any dramatic way, and that's actually part of the point. You were never going to have a real-time conversation with Proxima Centauri, regardless of what tonight's numbers say. You were never going to witness the actual current state of the galactic center or Andromeda, or anything meaningfully beyond your own immediate neighborhood, no matter how the physics eventually shook out. Nothing about your daily life changes because of the specific number of years separating you from a given star. What changes, if anything, is quieter than that. It's the way you might look up the next time you're somewhere dark enough to actually see the sky in full, not with the vague, unexamined assumption that you're looking at things exactly as they exist right now, but with the clear-eyed, scientifically grounded understanding of exactly how old the light reaching your eyes actually is, and exactly why, despite every wall we've described tonight, it was still worth building the instruments, running the numbers, and taking the time to find out. And that, in the end, is not a small consolation. Knowing exactly why now only ever belongs to you and to the small handful of people close enough to share it with you turns out to be its own quiet form of freedom, different from the freedom of instant, unlimited connection we sometimes imagine wanting, but real all the same, earned rather than given, built one careful measurement at a time by a species that refused to simply accept the delay without first understanding in complete and rigorous detail precisely what it was made of and precisely what it left standing undiminished right here, close enough to touch. Every measurement in tonight's program, every delay, every light year, every 26,000-year gap between us and our own galactic center was earned the same patient, unglamorous way, one careful observation stacked on top of another across generations of scientists who understood perfectly well they would never live to see the full picture completed and built it anyway. For exactly the same reason, the golden record was engraved in gold and sent outward into a silence it may never escape. Not because success was guaranteed, and not because the delay could ever be shortened, but because understanding the room you actually live in, walls and all, completely, honestly, and without flinching away from any of it, was always going to be worth doing for its own sake, regardless of whether the universe ever offered anything back in return. There is a particular kind of peace available in finally accepting this, the same kind of peace we found waiting at the end of our earlier exploration of the sheer scale of cosmic distance, and it doesn't require pretending the prison isn't real, and it doesn't require despairing over it either. It requires something quieter, simply noticing, clearly and honestly, exactly where the walls of your own light cone actually sit, without exaggeration and without denial, and choosing to spend your attention generously on everything fortunate enough to fall inside them. The person you can call right now and hear respond within a fraction of a second. No satellite delay, no light speed lag, just an ordinary, unremarkable, extraordinary instant of shared presence. The friend whose face changes expression in genuine, real time as you tell them something that matters to you, their surprise or their laughter arriving not as an echo of the past, but as an honest, undelayed response happening in the same breath as your own words. The warmth of a hand you can actually hold in the same instant you reach for it, sharing as close to truly as the universe ever permits any 2 points in space-time to share, the same brief, local, achingly rare present moment. Every star you will ever look up and see tonight is, in its own way, already gone from you, already moved on into some further, unknowable future you'll never witness, its light simply still arriving faithfully, patiently, carrying news of a now that stopped being now the instant it left. But the people close enough to actually share your light cone with you, close enough that the delay between you disappears into something smaller than either of you could ever consciously notice are not gone. They are, remarkably, actually here, sharing an actual present tense with you, something the vast majority of the universe, across its entire 93 billion light-year diameter, containing 2 trillion galaxies and however many hundreds of billions of stars scattered across every single one of them, will never, ever be able to offer any 2 points within it. That is not a small consolation. That might honestly be the entire point, the one true, unshakable comfort waiting quietly at the very center of an otherwise permanently delayed and endlessly patient universe. If tonight changed even slightly how you think about the delay hiding inside every glance up at the night sky, that's what this was for. If you'd like more evenings like this one, spent slowly walking through the actual physics governing our place in the universe, consider liking this video or subscribing to the channel. It genuinely helps this kind of long, patient exploration find its way to more curious minds who might need exactly this kind of quiet perspective tonight. And the next time you find yourself looking up at the stars, remember that every single point of light you're seeing is a message from somewhere that no longer exists in the form the light is showing you. A small, quiet reminder of just how rare and how precious it actually is to share a real, unmediated, undelayed present moment with anyone at all, anywhere, in the entire span of this vast and beautifully delayed universe. We just do our best, from right here, inside our own small, brightly lit corner of an otherwise permanently delayed cosmos, grateful for the light that reaches us, and grateful, most of all, for the people close enough to need no light at all to reach. Good night, and thank you sincerely for spending this particular stretch of real undelayed time with me.